Mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of this session is Understanding Oracle Automatic Storage Management, Availability and Hands-on Demo. And our guest speaker today is Akal Singh. He is Managing Director at Wave Solutions. Akal has spent past 15 years as Oracle DBA with skills into DBA support, high availability design and implementations, technical solutions, database designing, and as a corporate trainer. With deep technical industry knowledge, Akal has implemented many real-time projects on advanced database areas. He is also recognized as a senior corporate instructor and worked with Oracle University Training Division, providing more than 300 corporate trainings into database advanced concepts. Currently, he is the managing director, as I said, for Wave Solutions, which is mainly into Oracle database solutions and services. We expect this webinar to last for about an hour with approximately 45 minutes of presentation and remainder time for Q&A. So if you have any questions, please submit them using Questions tab on your GoToWebinar control panel. So without further delay, I introduce you all to our guest speaker. Over to you, Akal.
Yeah, thanks, Deepika. Thank you very much. Hi, everyone. Good evening, good afternoon, whatever the time from wherever you logged in, right? Let's start our session here about the ASM. So what is the prerequisite to understand this concept that minimum you should be having understanding about database? The Oracle database where consists of physical files, the set of files which are stored in the storage, right? So I have a couple of slides that I'll be sharing with you guys here on the screen, right? So first understand exactly about what is ASM, Automatic Storage Management. Instead of going through the slides, couple of slides, let me just take you guys to a diagram. I want to just go for a diagram here, right? So let's see here a few diagrams about the ASM part which I want to explain you guys. Okay, so if you look at database server, right? So in the database server, what we have the set of files. So what are the files you have? We have data files, right? Database consists of data files, redo log files, and control file. So minimum you require 4 table spaces, generally what we see after database creation. The one is system, sysocs, undo, temp, right? So minimum 4 files are taken up with those default table spaces, what we say. Apart from that, yeah, you will be creating additional more table spaces and you add more data files to them for your user requirement. And as the user data is growing day by day, the number of files are growing here, right? So you might have databases seen like with a huge size capacity, terabytes, not terabytes, even petabytes of storage requirement. And in that case, you have to have that much of space availability. Now, from where you are going to have the space, right? If I look at my server, in a server, you are going to accommodate the number of hard disks, right? You are going to place the hard disk. So how many hard disks you can have in your server? There's a question, right? How many hard disks you can have within a server in which you can have your data? Because until you understand the base, right, it's really hard to understand exactly what is the requirement or a purpose of the ASM. The base is here, the first thing, right there. Let's look at from a point where the database size is very small or a new industry or a new database got started up. There, right, you'll be buying a server, you'll be having a server with n number of disks in that. What is the size of the hard disk you choose? Now in the market, if you look at, right, you get different sizes. For desktop, normally we use 1 terabyte, 2 terabyte, 3 terabyte is also available in the market now, right? But if you look at the server side, right, the server side is always preferred to have the smaller the size. Because the smaller the size, it gives you more performance. What do you mean by performance again here, right? Okay. So there are two key values are there, words, terminologies what we tell. One is IO per second. I hope you will be knowing this one. So number of IOs per second, IOPS, the another is MBPS. How many IOs I am able to perform on a hard disk per second? This is calculated. This is depend based on number of IOs. So if you look at the hard disk, how the hard disk is placed internally, if you open the hard disk, right, you can see a magnetic plate, right, a steel magnetic plate in which your data is actually recorded, and there will be a header pointer, right, which is actually reading your data. There will be a header pointer which will be reading the data, and header need to move up and down to read the data, and this disk need to rotate. It's a magnetic disk, it has to rotate. So the faster the rotation, I can pick up more number of blocks. So I have to rotate the disk. The disk will be rotating here to pick up the data. The more rotations, you'll pick up more data. So that's all depends on your RPM. The hard disk RPM what you get. Generally in desktop we see 5400 RPM, right? 5400 RPMs rotates per minute happens for the disk, right? So that means you can understand how much data you are going to fetch based on the disk capacity. And the second thing, if you want, you can have even 7200 RPM hard disk. So obviously what I'm understanding now, right? So this the second 7200 RPM disk will give me more data in a, right, in a minute compared to the other one. Okay. Now the RPM, the rotates of the disk is going to, they are considered for the IOs per second. So how many IOs you're able to do, the faster the disk rotation, the more IOs you do, the faster the rotation. So that depends on the RPMs. If you want more performance, so obviously you have to look at the higher level of hard disk. But if you look at the server side, actually server side you'll have the hard disk starting with 7200 RPM, and even they go with not only 700, even you can have 10,000 RPMs. Not only 10,000, even you can get up to 15,000 RPM hard disk now, right? Okay, so the maximum, the more and the more rotation, the more data you are going to pick up. So I prefer to like to go, if you want a more performance, you like to go to 1500 RPM, but there are a few drawbacks are there because the more faster rotated, right, rotations, it generates a lot of heat because it's a mechanical instrument, hard disk. It generates a lot of heat and it can damage, the damage problems can arise and many other type of issues might arise. Second thing, the faster the rotations and the size of the disk capacity will be smaller here. It won't be like 1 terabyte with the 1500 RPM. No, it will be smaller the size. It's preferred to have a smaller size like 500 GB if possible. No, even less than that 300 GB is also possible. Even less than that, even 120 GB is also possible. The smaller the disk, the faster the rotation will be there with that. So now that depends on us, like what kind of configuration you are looking at. Generally for the desktops, people like to go with 1 terabyte, 2 terabyte or 3 terabyte with 5400, or mostly sometimes we get 7200 RPM disks, right? But coming to the server side, yeah, if your performance is depend on this, so if you want a more performance, the disk capacity will be smaller. Now if I choose the default one, like it's a normal one, the 300 GB, the hard disk capacity now from a server, like that, how many hard disks I can accommodate in a server. So server, we all know, it's a tower based server. When we talk about tower based server, right, they're limited, you're limited to a number of physical hard disks to be placed inside. Maximum, that depends on the controller you use, right? Because all these disks are connected to the controller. So on the motherboard, you'll be having a controller called as a SAS controller. So all these disks are connected to your SAS controller, and based on the motherboard having number of SAS controllers, that many hard disks you can connect. So it's like a one-to-one relation for them. So max, I think you can go up to 15 hard disks. So 15 hard disks, nothing but, right, up to, you can calculate now 15 hard disks, nothing but into 300 GB. 300 GB is the each hard disk capacity, right? This is the limitations. So it's not more than for me, all right, how much? It's few terabytes, not more than 4-5 terabytes. But if my database is bigger than that, because day by day data grows, this is the first basic thumb rule as a DBA we have to agree, accept. Data is always growing here. Look at your mobile, simple, that's enough, the example. The number of contacts are growing, the number of applications are growing, the number of SMSs are growing. We never think of deleting them, they always grow. Data everywhere, anywhere, it always grows. So the same thing happens with your database as data is growing, right? Now you require more and more space. So what should be done? You will always look for some extra space. So the extra space is provided, or extra additional disks are provided by extra storages. So you can get some extra storage machines, where you can have a lot of disks placed inside that storage box, right? So many disks you can have it inside that placed, and all these hard disks are accessible to you through a network. So there will be a connection between servers and storages, right? And that depends on the controller card what you're using here, the connectivity what you're using. Example, right? On your laptop, if your laptop disk got filled up, what we do? We are going to add some more space, right? Oh, sorry. If your laptop disk got completely filled up, what you do? You want more space. We are going to add a plug-in, a USB drive. Right, extra drive you are connecting through how? USB port. Which USB? You have USB 2.3. We like to go with USB 3, which gives me maximum data transfer, the faster IO. Perfect. More data transfer possible. Same thing while coming to this, right? The storage box you are attaching to a server, what kind of controller or connector you are going to use between them, right? So you can use the same SAS controller, but the IO will be limited there. So generally people prefer iSCSI or FC, that is fiber controller or fiber channels what we call. iSCSI and FC controller. So FC controllers, they can give you up to 16 gigabits per second. This is the IO bandwidth. So 16 gigabits per second, if you transfer into gigabytes, it will come around 1.8 GB per second. This is the transfer rate of these controllers. So the high-end companies, they prefer to go with FC controller, which gives me the maximum data transfer, because I have the storages now where I'm going to have a number of hard disks. You can go on add the disk. If the storage got filled up, you can add one more storage, and all these storages are connected through what? Connected through, right, through a network. So you are going to connect all of them through a network here. So all are connected through a network, through a switch. Right? So like this, as data is growing, now we got a solution. I need a storage or one or multiple storage with a lot of disks in that. The size, again, the size matters to your performance. So as the performance you're looking at, right, you require the faster rotated disks, faster rotation disks are required. The more RPM disks. The another is MBPS, which I told you here. There's one IOPS related to your performance. MBPS, right? How much amount of data you are able to transfer? How much data? Because data warehousing environments, your data is placed contiguously, or a huge amount of data you want to read, but the channel through which it is reading, that is very important here. The channel through which it is reading, that is important. How much data you are able to transfer per second? MBs of data per second. So mostly these two values are calculated in the one. MBPS is calculated in data warehousing kind of environment, in data warehousing environments, and the other one, right, IOPS, that is calculated in OLTP environments. OLTP, the user commitment is very high and they want their data immediately, sooner the faster, right? This is the requirement. So as you understand the requirement, like when you have your server and your data is going to be now placed or dumped in the storages with hundreds of disks based on the size you wanted. Now, as you got more and more number of disks, how you are going to manage them is another requirement now. Example, I'll take a very simple basic example here for that. Let me put a new screen here. Okay, so now let's look at this another diagram. Example, I have one server and I have 4 hard disks in it, right? And each hard disk size of 120 GB. Because there are two challenges are there as data is growing. As my data is growing, I am going on adding more and more disks. So what is the challenge here? First challenge, how you place your data, right? Where you are going to keep your data. Assume that I'll just put a few words here. Example, I'm going to have few disks. Example, each disk of 1 terabyte. So 4 terabytes I got totally, right? 4 lines I just kept on the left side. Each hard disk of 1 terabyte. But my database size is of only 2 terabyte. Do you like to keep all your files only in these two? If it is only 1 terabyte, do you want to keep all the files only in one? No. What we do, we divide the files, some files in the one day, some files in another, some files in another, some files in another. You're doing this distribution, right, to have a better IO and a better performance. This distribution is done manually in olden days because database size is very small and the number of disks also very less, so I'm able to manage the thing. But if you just imagine, if instead of 4 disks, now it became 40 disks, and you have to balance your data across all because you want to distribute your IO. I don't want IO to happen only on 1 or 2 disks or few disks. No. I want my IOs to happen on all the disks. IO distribution is required. So manually it is becoming a very big challenge. For 4 disks might be I can do, but 40 hard disks, 40 disks, right? It's not possible. So what is required here? That is the main thing here to understand. So now, if I got 4 disks and each disk size of 120 GB, 120 GB each, which I'm saying here now, if each disk size of 120 GB, then what is the total size it's going to become? 480 GB, right? So we got the size of total 480 GB. So from this 480 GB, I want to create a D drive, let me create a C drive in this machine. So if I'm using the disk 1, I'm creating the C drive and I want to create another D drive using some space, right? So I selected some space for C drive like a 40 GB, done, and the remaining 80 GB which is left, I'm giving it for D drive. So what is the total remaining space is left now, right? We have total how much space? In the remaining 3 disks, around 360 GB. So we got 360 GB left here. C and D drive is done. I want to create a E drive. I want to create a E drive with a size. What size you want to give? Okay, so from 360, I want to allocate 160 GB. Or I want to give 200 GB. Or better, let me take the complete space, 360 GB. So is it possible? Can you create a E drive like this, having the sizes below mentioned? If you just think about Windows and go to the Windows disk management, right, with disk management tool, there you can see 4 disks, right? And right click, and when you say create a partition, what is the size max you can give on the disk? The size of the hard disk, not more than that, right? So you can create only a partition of 120 GB, not more than that, because my disk size is of only 120. But I want to create a partition of 160 GB or more than that, and that is not possible. By default, your operating system tools, they won't allow or they won't provide with this, right? So that's why each disk is created as a mount point. Here, if I look at that, right, each disk I'm going to create one mount point of each size. If it is 1 terabyte, 1 terabyte, 1 terabyte each. So I'll be giving in a Linux, normally we give a mount point like /disk1, right, /disk2, /disk3, and you are managing all your data to be placed across all these disks. Data distribution manually done. So one problem issue is the performance. The performance comes in picture. One thing, the manageability is really hard as you grow. If you have 20 disks, I can't imagine having disk 1, 2, 3, 4, 5, 6 like this. The mount points up to 20. And manually you distributing data there, keeping your files in separate disks, really hard. One thing, manageability is the first problem. The second problem, performance. So automatically performance is affected there. So performance is another key here, right? These are the two. There's one more requirement is there. In case, because it's a production database, in some reason, if my hard disk, one of the hard disk got failed, I'll be losing all the data which is there in the disk. The disk is not accessible, and might be your database can go down. Possible? Yes. If your system data files or undos are there in that, the instance will completely go down. So what you need to do? You have to replace the disk with a new hard disk. After replacing, do you have a backup? Yes. Now restore your backup into this. How much time it will take? That depends on the disk size. Now imagine if it is a 1 terabyte of disk you are using, and imagine how much time it could take to restore complete 1 terabyte of data, and recovery need to be done for the whole 1 terabyte of data. Instead of that having a bigger size, I would be using a smaller one, 300 GB. So I have to restore only 300 GB of data, and the recovery should be done only for 300 GB. That means the faster recovery will happen, right? That's why in production servers, people like to have the smaller disk size. One, the performance will be good. Second, availability. Right, in case of any crash also, immediately I can replace and I can restore and recover. Within less time I can bring back my database. So this time, the duration of time is called unavailable or a downtime. So my database is completely down for this duration of time. What can be done? So these are the 1 to 3 main questions are there, queries are there. The one because as data is growing, the number of disks are growing, manageability. Second, performance. And one more is availability. These are the big concerns as databases are growing. So to support this, already few tools are in the market, because my requirement here for easier management purpose, what is it? I want to have a E drive of only 360 GB, and I want to keep all my data into that. But you are getting only 120 hard disks. So it's not possible by default. So what can be done? When I raise a request, okay, so there's some product is coming up in the market, or it's already there. They're claiming that we are going to provide you the solution called as a volume manager. Volume manager. Right. Okay, I'm just cleaning up this above lines because I want it to use it. Right. Okay, so volume manager is came in the market, and they're saying, boss, we'll help you for your requirement. What is it? All the three basic, the challenges, what you see here, these are the challenges, requirement, right? We will take care. How? The volume manager says, we are going to help you by allowing you to create a single logical drive called E drive. How it is possible? By grouping all these multiple disks into this logical entity. So with the help of volume manager, I'm able to group these multiple disks into logical entity called as the E drive. Or if it is a Linux /disk1 mount point you want, you can create. Is it only the one grouping? Because by grouping, what happened? The manageability become easier, right? Now, from a administrator point of view, it is only one drive for you to manage. Or from DBA point of view, it is only one drive. All the 10 disks are grouped into one logical drive. So manageability is fine, but what about performance and availability, right? We have other more concerns. To gain this, volume managers are saying, yes, we provide you even the performance plus availability things. How this is possible, performance and availability additionally, right, with the concept called RAID concept. So you have to configure the RAIDs. So there are different levels of RAIDs available like RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5, right? So like this, there are multiple RAIDs are available. But most popularly commonly used are RAID 0, RAID 1 and RAID 5. Okay, so now in these three RAIDs, what we see here, what is RAID 0 means? RAID 0 by default it will perform, RAID 0 means it is striping your data across all the disks. If I look at this, right, if I create an E drive selecting all the three, my data will be striped across all the three. Means if I'm creating a 15 MB file, so 5 MB of content is written here, 5 MB is here, 5 MB is here. Data is written to all the three. Example, I'm creating some content. Let me take some content value like ABC. So A will be written here and B will be written here and C will be written here. So data is distributed across all the disks. This is called the striping. Data was striped across all the disks by configuring RAID 0. If you configure your E drive with RAID 0, your data will be striped. So what is the benefit? You are going to gain the performance because you have multiple CPU architecture in the server. The multiple CPUs are going to now parallelly write to multiple disks and parallelly they are able to read it. So faster and the performance is good. What about the RAID, other concepts, RAID 1 and 5? So it says that RAID 1 is nothing but your mirroring of data, because availability is another point I'm looking at. What do you mean by availability? In case if one of the disk is lost, I'm losing this content, right? This data accessible to me? No, right? So in that case, downtime is coming in picture. See, the downtime is coming in picture and you have to wait, and the DBA administrator need to replace the disk, restore and recover, give back to you. The total time, whatever it is taken, considered as a downtime. So this volume manager says, no need of any downtime. I will help you. How you are going to help? So whatever content I'm writing in each disk, if you configure RAID 1, RAID 0 plus 1, the first configuration which we discuss is RAID 0. The another one is RAID 0 plus 1. We're talking about RAID 0 plus 1. So if you talk about RAID 0 plus 1, I'm doing here what? The striping is done. First the striping ABC is written, and whatever content written in the disk, the same gets mirrored into another disk. So whatever I wrote it there A, the same is written into another. The same content, the B is mirrored here, another disk. C gets mirrored into another disk. Right? Okay. So this way the mirroring happens. So what is the benefit? Now in this example, if the disk goes or fails, my database instance is not going down. Why? Because it's able to access all its data. We have A, we are able to access B, and even I got my C available here. The database instance still running without any downtime, even the disk fails. That's the thing. Okay, that's really awesome, great. What's next? We have RAID 5. What do you mean by RAID 5? RAID 5 is nothing but the parity. Right? Parity. What is this RAID 5 parity will do? Unfortunately, or a bad luck scenario, how many disks, generally people expect, okay, might be one disk might be failing, but how many disks will be failed in a bad to bad scenario? Please don't say all. It never happens. Right? Generally we think of only one. Very bad luck or bad scenario is nothing but two, not more than. Very simple, man. You're going with your family out of station, you took your four-wheeler and you're going, right? How many stepneys you carry? One or four? We carry only one, right? Your bad luck starts when two tires are failed at the same time. The same thing here, right? Generally we plan for once. That is called as a single point of failure. But the bad luck is nothing but two got failed. So in case if the two got failed, the volume manager says, we give you more availability. How? By replicating the data into multiple more disks. How it is that? Okay, so whatever I wrote in A and A in the second is the same copy I'm writing into another disk. So two copies, additional two copies are maintained. B and B, right, it is writing into another. C and C, it is writing into another. Now in this scenario, if my disk fails, what two disks got failed at a time, so still you are able to access your ABC. That means your database availability is still there. So I'm going to provide you the availability. So like this, your basic requirements, what you have, manageability, performance, availability, they are handled or taken care by what? Volume managers. They are providing you, by volume managers, you can group them with the RAID concepts configurations, you can gain the performance availability. So Oracle also came in picture, and Oracle saying, boss, we also provided the similar solution what you're looking at. How? With the help of ASM. So I'm asking Oracle, can you please explain about the ASM? They say that, right, with the help of ASM, even you can group your disks, and the name is called as a disk group. We call it as disk group. So you can select multiple disks and create one logical entity called as disk group. It's a logical entity. Generally we give the name, default names like a data, right, FRA, or you can give any name. You can give my name also, Akal, and another disk group as same, right, but it should be meaningful always. So now a disk group can be created, which is going to help you for the manageability become easier. So you can take 10 disks and group them into one disk group. and all data, all your user data can be kept in the same disk group. It is looks like the same like my E drive, nothing changed, only the name or terminologies are there, change, but the concepts are completely same. Now, if I ask my ASM boss, what about the performance and availability? Oracle says when you create a disk group, by default striping will be done. Striping is by default. Oh, by default striping is the RAID 0 concept what we discussed, right? RAID 0, right? So this way I am going to give you the performance with that because data was striped, this ABC, how it was written. So always whenever you write any data in a disk group, data will be written to all the disks. Data gets always striped, balanced across all the disks. This gives me the performance, perfectly done. Okay, what about the other things like manageability is anyhow disk group is done, performance is by default given to you with the disk group. What about availability? If you're talking about availability, you have few options are there. There is an option called redundancy. You have to choose the redundancy options. So what options we have in the redundancy, right? You have an option 1 to 3 options are given. You have to choose. The one is called as external, the another is normal, and the another last is high, right? So we got external, normal, and high. External is nothing but no redundancy. So redundancy is nothing but no. But what about normal? Normal is similar to your RAID 1. RAID 1, what it is doing? The mirroring part. How many copies it is having? 2 copies are maintained, right? So it is going to maintain 2 copies for you. If I talk about the high, for the high it is something like a RAID 5. RAID 5, how many copies you have? 3 copies. So now you have a choice. You can go with the ASM, which gives you the performance by grouping the disks into single disk group, and performance is given by default, manageability performance, plus availability is given with the concept called redundancy option. So in the ASM, you can select the redundancy option. If you select external, you don't want any no mirroring, so mirroring won't be happen. Here 2 copies are maintained, and here the 3 copies are maintained in the case of high. I hope you guys got understood exactly, right? It's a comparative which I tried to show you with the volume manager. So now you have a choice. You can go with volume manager or ASM, but with the ASM there is one more extra benefit I can say, because ASM is purely designed from database point of view. Looking at your database requirement, the IO requirement, right? So they are fine-tuned version by version, and they are capable of managing a huge volume of data and huge databases. That's the beauty of that. So let's look at the ASM few slides, and then I'll take you to this what we call a small demo. Right? So ASM is a purpose-built cluster file system and a volume manager. So you can see here on this, right? On top of operating system, you have a choice. You can go with volume manager, or even you can go with a ASM. Right? So you can keep your databases in the volume manager storage, or you can keep your database files in the ASM disk groups, what we call. We call it as a disk groups. So what is the ASM disk group? ASM disk group is a fundamental object that ASM manages, right? His job is to manage, consist of one or more ASM disks. The disk you are going to group them, and is a basis for ASM storage files. So your ASM, your files, database files will be stored inside this one. So you have three choices options are given. So the disk group redundancy levels are there: normal, high, and external. So it's like a no mirroring, 3 copies and 2 copies. So if you create your disk group, so example, this is a slide we are seeing here, right? You have a disk group with 1, 2, 3, 4 disks. These are the 4 disks I used it. So what happens? Data is actually balanced here across all the disks you can see. In the traditional way, you have to decide where you want to keep your files, and most of the IOs could happen only on one of the disks. But if you go with ASM, data is acrossly distributed all the disks, and the IOs are performed very well, and performance is automatically improved. Let's look at the ASM disk group for this one, how it is done. I'll show you a demo for this. Okay, so now I logged into one of my machine. Let me log in as grid, because we have the grid infrastructure, because 11G R2 onwards, right? You need to install, if you want ASM, we have a separate software called grid infra. I installed it already, and see I can check that ps-ef grep grid, that instance is also running with the grid user called as plus ASM. A ASM instance is running and a listener is also running, and both are registered with my grid infra. Right? Okay, let's see that grid infra contains one component called as Oracle restart. So CRSCTL status resource -t, the command to see the status of your services registered with your Oracle restart. So I can see here my ASM instance is online, my listener is online, and I have the default two disk groups data FRA, and the database is running as a prod. Okay, so database, there is a database called prod is running in this. Fine, let it be. I'm going to the prod now. So let me check prod is running as a which user, grep pmon, ps-ef grep pmon. I see it is running as which user, Oracle user. So I'm going to open one more session for the Oracle user. Let me open as login as Oracle. Yeah. Right. So I logged into the Oracle user. I want to just connect to my database and inquire about the files where I have SQL plus access DBA. Sorry, I have to set my environment, right? Export Oracle SID, or let me say .bash underscore profile. We have PRMY, sorry. So .ora /etc ora tab. Let me check. We have one more database called prod. So /space ora en. I'm setting the environment for prod. Then I'm setting the environment for prod. It is done. Okay, let me clear the screen now. SQL plus access DBA. I want to just inquire my files where they are kept. Select name from v $data file. I see all my files are in a disk group called data. Right, data. Okay, let it be. I'll create another disk group here for a demonstration. I'll create two disk groups and two user accounts. So first I need a disk group. So how to create a disk group? I can use multiple ways. I can go through ASM CMD. I can try using SQL Plus. Even I can try using ASM CA, or even I can try using Enterprise Manager. All these different ways we can try. Okay, if you want to try with ASMCA, right? We require a VNC graphical. So I'm starting a VNC session with my grid user, VNC server :3 on the port. Right? I started. Let me open a VNC viewer from my window. VNC viewer. Let me give the IP 192.168.56.21:3. 3 is the port number which I gave for this, right? And now continue and login. Password, I gave a default password. Right, password enter, and you are now logged in. So after logging in, now you can type ASMCA if your environment is set. I'm invoking the ASM configuration assistant, a graphical tool through which, Java based tool through which you can manage your disks. Now if you look at here, I see data and FRA2 disk groups are available. Let me just click on create. I'm creating two disk groups. One is called data with external, because in external, do we have redundancy there? No, we don't have any redundancy in the external, right? No redundancy. So I'm selecting here externally. So I'm creating one disk group, that is data underscore external, and I'm going to select the disk. So let me select the disks here and let me keep it remember. So 5, 6, 7. that is SDC, SDC5, C6, C7 I'm selecting and I'm saying click OK. Done. 5, 6, 7 I used. Let me just keep a note here in the notepad. So we created data underscore extension, that is with /dev SDC 5, 6 and 7. Okay, in the notepad I just kept it done. Come back and click OK. Let me create one more. Mention that this group name. So I'm going to say data underscore normal. Another disk group, data underscore normal I mentioned, NOR, and I'm going to mention here where it is 5, 6, 7 are done. So let me take 8, 9 and SDC 10, right? Okay, so the selection here, the normal means the mirroring, 2 copies should be maintained. Right, so we got 2 disk groups created, perfectly done. Let me click and I can see here my data external and data normal. Both are mounted, external redundancy, normal redundancy I can see here. Let me come out of it, exit. Just close this window, VNC not needed anymore. Now let me go back to my database side. I want to create 2 table spaces here. Where I want to create this? In those 2 disk groups. How to create them? So create table space. I'm going to say data table space in where? First external, right? And data files where I want it? I want it in data underscore external, right? Size of 200 MB. So create table space name. I simply created a table space. Table space name is data ts underscore extension, right? And this group name is data underscore. This is the one. Can I see that? Select name from right. Select file name, comma table space name from db underscore data underscore files. Column file name, format A55, set line 150. Let me format them. I can see this is the table space which I created with a file, right? Available where? In data underscore external. Perfect. Let me create one more table space, right? Create table space, data underscore, data ts underscore normal, ts data table space underscore normal, right? Data file where I want this data file plus data underscore normal, right? Data file and size of same because the mirroring happens here, so I need more space. So let me give 300 MB. Done. Okay. So now I got 2 table spaces. One is data ts. I can just inquire with this. So we got data ts external and data table space normal. And this table space is created in which disk group? Normal, and the other one is in external. Let me create one user. So create user Axwave identified by, right, saying the password, my name. And but again I want to give default table space data. So the default table space is which one? I want to give him. Okay, sorry, default table space. I want to give this one, the external one, right? Quota unlimited on this table space and quota unlimited on this table space, right? So we created a user. The default table space we mentioned as this one external, and we gave unlimited quota. He can use the maximum space of ext table space, and he can use even the maximum space of normal. Perfectly done? Done. Okay, I have to grant some privileges to him, right? So grant deviate to Uxwave. So connect Uxwave with the password sync, right? So do we have any users? No, none. Select star from tab, nothing, right? So I want to create a table. I hope we have Scott, right? So let me create a table selecting from Scott. So create table emp underscore, because I'll be creating in a default table space. What is my default table space? Ext, right? So emp underscore ext. I'm creating a table space. In which table space I want? Data underscore external as select star from Scott.emp, right? I'm selecting from Scott and creating a table, right? Perfectly, a table got created. In which table space created? In the external table space we created. Select star from tab. We got one. Let me create one more table. Create table name emp underscore normal table space. In which table space you wanted this to be created? In this table space as select star from Scott.emp. Perfect. So we got two tables in two different table spaces, and those table spaces are in two different disk groups. One is the external without mirroring, the another is normal with mirroring. So we got two things. Now let me open another few additional sessions here. uh, I'll be opening another duplicate session for grid user. Grid. Let me go to U01 app Oracle diagnostic destination for ASM. Sorry. So parameter dump, right? Where is my dump destination? This is the destination. CD ASM plus ASM and trace ls. I can see there is a trace alert log file will be there here. I can see the alert log file tail-f alert log. I'm just keeping a monitor on that one, and I'll keep it a little bit minimized, and I'll keep it on the lower side. And let me open one more duplicate session with this duplicate session and log in as Oracle, and I want to go to /U01 app Oracle diag rdbms, right? Prod ls prod, then prod trace tail-f alert log. I want to just look at the alert log information. I want to have a monitoring, that's all. Fine, perfectly. I opened two sessions here, one for ASM home, another for Oracle home. Now let me come to this session, right? There is one window. This is with the grid, let it be, and I'm having one more window. This is the where user is going to actually work. What I will do here, while user is working or accessing the table, I'll insert few records so that I want to check the data was distributed. So I can use Enterprise Manager for that. I can check, even view the information. So login as sys, password is Oracle. I'm logging into the Enterprise Manager of my database console. From there you can navigate to your ASM. Right? You can see the ASM part here. Just go to these groups. So you can do your ASM administration management, everything from here. If you want, you can mount, unmount, rebalance, check, delete, or even you can create it here. So you've got all the disks, and you can see the space, external and normal, right? Normal, that is nothing but redundancy, double the copy. If I click on external, I'm just clicking on external, and I see the space got used here below, right? So we have the space used below, you can see that. I'll do some inserts, and I want to check and inquire how this is going to happen. So I'm doing few inserts, insert into emp underscore, that is, what is it? External, right? External, select star from emp underscore external. So I'm inserting few records. If you let me insert few thousands of them. I hope, let me say commit and check. Might be some space got used. Let me refresh the screen. Is it still growing or not? I want to just check. It is still showing 9% as used, right? Okay, so might be, let me insert few more. Insert into EMP, what is that? External, select star from EMP underscore external. Right, I inserted few more. Let me insert few more and check. Fine, we got good number of records. Let me just refresh and check. So this is a enterprise, so it will take some few couple of seconds to refresh. Let me check refreshing them. Or even you can try from the ASM views. We have ASM, and from their views also you can inquire that. Just I'm trying to show you that the data gets balanced across all the 3 disks. So we have the 3 disks here. Data is available in them. Let me insert some more data, few more rows. It's already more. It's a huge data. Let me just commit. Okay, let it be. Fine. Let me go to the another table and insert the records in that too. Insert into EMP underscore normal. Select star from EMP underscore normal. Right. So we are inserting few more records here also. Let me do insert. Commit. I just committed. Let me go back to the ASM disk groups. I can see now my data normal external the same sizes. Let me again refresh them. So I hope we have created these tables in the same table spaces, right? Select start from tab. Select segment name, comma, table space name, comma, bytes by 1024 by 1024 from db underscore segments where owner equal to where. So column segment name format A15. Right, just 5 minutes, Deepika will be done with the session. Okay, right. So we got this size 80 MB was occupied. Okay, let me insert few more things. Insert into EMP underscore external. Select star from EMP underscore external. Let me insert few more rows. I'm just doubling them. Right, let me commit. So insert into EMP underscore normal. Select star from EMP underscore normal. I'm inserting few more in the EMP normal even. And let me say commit. I want to just check in the enterprise that it is using all the disk groups or all the disks in a disk group. So let me go to the normal, right? It is, you can see the data was distributed across all the 3. If you go back, check the data underscore external, right? Percentage of used. Okay, so let it be that, right? It is taking some time to refresh, I hope. Fine, just come to the another part, the availability part which I'm telling you discussing, right? So let's look at that one. Let me minimize this window, enterprise. Fine, we have the log files available here. Let me do one thing. I'm opening one session for root, su-login as root, and I will start reading data from one table that is emp underscore external, right? So select, let me exit the session and log in again. Select star from emp underscore or select star from tab. Sorry, connect to Uxwave. Oh, the tables are created. Why? Yeah, that's correct. So connect to Uxwave and the password is Oracle. Sorry. Connected. Select star from tab. Select star from emp underscore external. I'm trying to select from emp underscore external. At the same time, what happened? One of the disks got failed. So which one I'm using for emp external? I think we have a list here, 5, 6, 7. So I'll do one thing. I'll go to 5. I'll just SDC 5. I'll format it. I'll delete the content from there. How? Using dd command. Input file dev/0 value. Output file on which one I want to write this one. I want to write it on /dev/sdc5. SDC5. Right now, block size equal to 1024 and count equal to something like 1,000. I just written some content there, overwritten. Let's start reading there. One of the disk got failed. Let me delete with few more values here. Okay. Still rating. Okay, fine, great. But actually, I would have did a bounce before this because the content is there in the memory, right? Now, if I start up, it won't come again. Right. I think we got hit now. What is that? The Oracle data block corrupted in the file 6. Right? You can see the block got corrected and your query got terminated here. You can see that the query got terminated, unable to proceed because the file is missing and you're missing some data from there. Done? Okay, so now let me look for the another table. We have another table. What is that? Select star from EMP. What is the other table? Select star from EMP underscore normal. But for that, again, I want to delete. So which I used here, 5, 6, 7. So 8, 9, 10 is used by normal, right? So let me do the same thing with 8. 8 or 9 or 10, anyone. So let's take 8 and I'm making it 0. And now I'm running this select query. What happens to my query? And you can see here in the both the log files, right? It is stopped and it is continuing. Wait. All right, still waiting. I'm waiting for error to occur because one of the disks got failed, and you can see now you're getting errors in the alert log, right? You're getting errors. You can see here. Corrupt block found. Corrupt block found. So what is happening to my query? Still my query is running there. I can see my query is running. Query is still continuing. Right? It is reading from the mirror copy of that. It is reading from the mirror copy. Right? It will show you the information also here in the outcome. It starts reading the mirror copy. So data was given continuously. So this is what happening here now. It is reading from the mirror copy because we got multiple copies of it, and it is reading from the mirror copies. Right? So this is the thing, availability means your instance is still running, users are still working, accessing data from the mirror copies. So that's what is given here. So even the primary copy is lost, no problem. It's automatically going to rebalance here. The data going to be rebalanced. Example, one of the disks got failed here. One of the disks got failed, right? So data gets again rebalanced. So whatever content here, do we have a mirror copy? No, I'll do a mirror copy here. That mirror copy done. So for green, we have a mirror copy here, but for this, we don't have a mirror copy. It is going to perform a mirror copy. Why? Because after rebalancing, again, if another disk fails, still I have my data available. Perfect. Okay, so the time constant is there, so I have to stop the session here, right? I hope you understood the main part about the availability.
Yeah, thank you, Akal. We would request you to take one or two questions.
Yeah, sure.
Yeah, thank you.
Okay, so any questions, please? Yeah, there's a sign. Anant Wag, right? I think he's left. Okay, it is Beer. RAID 0 is different. RAID 0 is only striping, and RAID 0 plus 1, it is doing striping plus mirroring. That is for just beer. Right? You asked about compared to RAID 0, is the performance of RAID 0 plus 1 will be low. It is giving you the availability, right? So availability and performance are two different corners always of a coin. Right? You can't see both them at the same time. Any questions, please? Any more? Okay, so Vihang, Ashik, you also asked me something like about appreciate if you could provide best approach for changing redundancy from high to normal or minimum to downtime. You can't change the redundancy once the disk groups are created. Only thing that you have to create a new disk group and move your data to the new disk group. Any more questions, please? Okay, so Hemal Shah, if we have hardware mirroring, would the query fails? No. So right, the mirroring is of two types. One is the hardware based, and there is a software based. So both are responsible. Both are giving you the high availability actually. That's why you can use. You have a choice. You can go with hardware mirroring because hardware mirrors are very expensive. At the hardware level, hardware RAID controllers are required to do the mirroring. So another is a software-based mirroring that is again a better than a cheaper one, but it both gives you the high availability. Nothing difference. So Sanjeev Rumale, your question is what is the best way to move a non-ASM database to ASM? Simple, use RMAN. Right, RMAN is the best way you can try. Manually also you can try do that one. Another method. Jaydev Swan, your question is it advisable to use table space as auto? Okay, so you are talking about locally managed table spaces, right? Locally managed table space, we have one is auto, that is system defines the extent size. Another is uniform, where you are going to decide what should be the size. That all depends on you. If you want to define the size of your extent, you can define, or you can leave it to system. So auto will be the most of the cases is the default one. Hemal Shah, you're saying that can we use the learns from volume manager for creating ASM disk groups? Yes, you can create, but it's not recommended. Because again, volume manager plus ASM you're doing, right? That should not be done. So MD Shamim, your question is, instead of using ASM, shall I use storage for performance and manageability? At the storage level, yeah, you can do that by doing hardware mirroring, and the rate concepts can be implemented there. So you have to do a hardware rate. Possible, but expensive. And you require resource, because as a DBA, you don't know how to do that part, right? You need to hire another person like who's system admin or the storage administrator who can do that with expertise. Else, now a single DBA can do all this part, right? So managing, mirroring, right? Everything can be done only by a DBA itself. That's the benefit. Striping happens byte-wise or block-wise? It's byte-wise. Which is better option, external or normal? External, see, external you're not doing any mirroring in that. Normal is always preferred and recommended where you're doing a mirroring. Now this depends on data availability. So how critical data is yours? If you feel that it's not data is nowhere critical for me, you can go for external. If data is critical, you can go for normal, or better, you can go for high. Yep, there's any other questions? Anyone? I got many more, but I'm able to just see and read a few, and I'm trying to answer them as many as possible. Okay, so Tejas Patel, your question is, my question is, what are the permissions difference between root level disk permissions and Oracle grid permissions required? As because the disks which are used by grid, it requires the grid user permission. So if you look here, if you look at the screen, right, so you can see in that I'm going to cd/dev ls-l, I'm giving grep sdc. You can see here I gave the permission as a grid, so as a grid user he should be able to access. Okay, Rakhi Krishnan, your question is, what is the ASM power limit recommended? Default is 1. ASM power limit is 1, means in case of a rebalancing, one of the disk fails, automatically data gets mirrored into another disk. The previous slide what you seen here, if I just go back to this slide, right? So the previous slide what we seen here, right? You can see here in this now slide. So what happened? We have actually 3 disks are there. We have 3 disks. 3 disks are there. So one disk got failed. Still I have my data 1, 2 and 3 colors. All the 3 colors are there because primary and mirror copies were there. But immediately rebalancing happens where the copies are going to be maintained immediately after rebalancing the disk like this. Why? To improve the availability. Why? Because even one another disk fails, still I have my data available in one. To improve availability, this thing is done. And that who will move all these blocks? Your ASM library will be doing. Sorry, ASM, what is it called? ASM, RBEL and ARB, sorry, yeah, RBEL and ARB process is there. That is responsive. So how many ARB processes you wanted? The more the ARB, right, the more the ARB, the faster the rebalancing. So that means that how many ARB, that depends on the power limit. Default is 1. Without affecting performance, rebalancing happens. You want immediate rebalancing to done, right, to be happen, then you can increase the power limit up to 11, right? Any questions, please?
Yeah, I think, Akal, with that, we come to the end of the session. So thank you so much for conducting this really
All right.
insightful presentation and Q&A session. It was indeed a great one.
Thank you. Thanks, everyone. Thank you very much. So in case of any queries, you can reach me anytime, right? So you can go to my site, that is axwavetrainings.com, and you can get my email ID there and you can drop me a mail. Thanks,
Yeah,
everyone. Thanks,
yeah,
Deepika, too.
Thank you. We'd also like to thank all our participants for the support in making this webinar a huge success. For those of you whose questions have not been answered, I'll just share with you how you can basically post your questions. To go to the webinar page on techgeek.com, and you have a Q&A section there on the same page. You should be able to post your questions, and whenever Akal has time, he will be able to answer, and it will be a active page, and we'll be able to answer in a forum kind of a format.
Yeah, that
So,
will be great. Right.
yeah. Thank you, everyone. Thanks a lot for your time, and thank you for joining us. Bye
Thanks
bye.
again. Bye bye.